And welcome everybody to the Daily Space Weather, a regular feature here at SNN, Least Busted Name in News. I'm your host Dan, aka smAsho. Lots of stuff to talk about today. We're going to blast through it as we've got an incoming coronal hole wind stream, an incoming coronal mass ejection, and an incoming geomagnetic storm. First thing we're going to do here is we're going to show you what's going on with the sun in the past few days, going back to when the coronal mass ejection that has hurled protons in your direction occurred, and that happened right there. I'll rock that back. And there you can see a C-class solar flare. It was a large C-class in the high range of C-class, nearly an M-class flare. And that has hurled a bunch of hydrogen nuclei toward planet Earth. At the same time that a coronal hole wind stream was already on the way, and that coronal hole wind stream has been caught up to by the coronal mass ejection, most likely. And that's what we're going to be showing you throughout the video today. There you have that. Now, we've got some problems with the HelioViewer movies, the SDO data, the SOHO data, so the format may look a little differently. That's why. And don't be surprised over the next few days to see some communications problems, satellite outages, and so on. It doesn't mean that NASA is hiding the truth from you. It means that these devices have shut down to prevent them from being damaged. The radio flux has come down to 82, so the 10.7 centimeter radio flux, and thanks to our new viewers out there, is a measurement of the radio output of the solar outer corona, and that's why we made that graphic for you there. There's the 1 year chart of that. And I put up the sunspot number progression to the top of the last cycle. So there's the top of solar cycle 24. The monthly value was at 130 at the last solar max. We almost made it all the way to 100, actually, recently. So look for that to update soon. There's the radio flux graph, and you can see how proportional the sunspot number and the radio flux are. That's why we look at both of those figures. Now, those measurements are all done on the Earth portion of the sun. Let's take a look at stereo A. Here's the latest from stereo A. You can also see Venus there, and we see a bunch of plasma here in the Earth-facing side, suspended out in the corona. There is a sunspot sort of in the Earth-facing zone. It's moved west. It's rotated to the west of the heliospheric prime meridian, and we haven't seen any release. Don't be surprised to see additional coronal mass ejections released, as that is a large series of filaments in the corona in the Earth-facing vicinity. So stereo A is located at Lagrange point 5, and that's sort of the view from stereo A. And next we're going to show you the Enlil spiral, which will show you the coronal mass ejection and the forecast. So here we are. Let's see. It's the 9th, so we're right around this point right here. And indeed, the coronal hole wind stream looks like it is already arriving. We see an increase in the KP index. We'll cover it in a moment. And you can see that long black line there. That is the coronal hole wind stream. And then you can see the coronal mass ejection propagating on the 7th. The solar flare that ejected that coronal material occurred at about 16:30 Universal Time on the 7th. And there you can see the strike is forecasted for the coronal mass ejection. According to NOAA, that's the second spike you see there in the upper pane. So you see where the yellow needle is now. That's the expected right around midnight tonight, Universal Time, first thing in the morning, tomorrow on the 10th. So we're expecting an increase in the density, then a decrease in the density, then an increase in the velocity from the coronal hole wind stream at the same time that the coronal mass ejection strikes. The way they'll interact is, well, the coronal hole wind stream is from a south pole oriented coronal hole, And the umbral polarity of the coronal mass ejection was also south solar polar polarity. So for instance, the coronal mass ejection could actually accelerate part of the coronal hole wind stream, as they may exert a little bit of a pushing force on each other. They could also cause some heating. Anyway, there's the Enlil spiral, including the forecast and a good view of the modeling for the coronal mass ejection. And here at the Smash News Network, we endeavor to provide you with accurate information on the regs. Again, thanks to our new viewers. And again, we are seeing some issues with helioviewer.org. We're going to show you some great solar videos here. Regardless, here's one day of activity from the SDO website. And you can see a large series of coronal holes here in the north portion of the sun. Those are what have sent the coronal hole wind stream. And let's move on to some more data here. Stay tuned to the end of the video. We'll show you some close-ups and indeed some images of the coronal mass ejection solar flare scenario that happened on the 7th. Don't forget to check us out on social media. We've got a group called Entropy Busters on Facebook, as well as facebook.com/smashamash. I'm also on Twitter, exclusive content there. Don't forget to join us for the solstice, which will happen on December 21st at 5:02 and 20 seconds Allentown time. I'm located in Lehigh Valley. We'll be streaming live at the moment to wish you a happy solstice. And if you enjoy the content, please press like and subscribe on YouTube. Press the notification bell. Don't forget to check out the video that we made the night of the coronal mass ejection, entitled M-Class Solar Flare and Coronal Mass Ejection, CME, SDO, etc. That's a great video, and it's become quite popular. We're also on BitChute, thanks to our new subscribers over there at BitChute. Now up to 262 subscribers at BitChute. Thanks to our new subscribers at Twitch. Twitch.tv/smashamash is where we're currently streaming, and they've got a great mobile app as well. Perhaps download that. You'll get notifications when we go live. We don't always go live on Twitch, as we put exclusive content on all of our social media sites. Also, I would invite all of our viewers to check out smashamash.com. You can see all the rest of our social media there. We're on Gab, Minds, Patreon, Instagram, Locals, etc. Also, check out our stores and our forum. We spend lots of time talking about whether or not you're safe. Are you safe yet? Well, our channel, part of the purpose of our channel is to make you slightly more safe, in that if you understand the physics, you may be able to tell your friends and foes about emerging science, threats, etc. Are you safe yet? Pick up some merch. You can link to it all at smashomash.com. Since all things matter, today's featured product will be the All Things Matter girl shirt in black. All things matter, folks. Congratulations, you're made of condensed matter, and you matter. You matter, your job matters, etc. And let's talk cosmology for a brief moment. We'll do a cosmology segment and look up a random object. So we're going to use the Neil Gorell Swift Bat X-ray Observatory, the X-ray telescope. I've generated a random number. It's 205. Let's see what that might be. We'll scroll down the list. 205 is a quasar. Quasar B0607-157. There are the X-ray transient outbursts. Not so transient, as it's got a quite steady output of X-ray flux. There's the daily and the 30-day X-ray flux from quasar B0607-157. Let's see if we can get a glimpse of it on Simbad. We'll also take a look on Aladdin Light. There it is on Simbad. It looks like there's a jet. No surprise there. Probably the one not facing us, as quasars are active galactic nuclei, where you're looking down the polar field. Could be a foreground object, as the crosshair is on the dimmer portion. So let's take a look at it on the Chandra, which is an X-ray image. It's not showing up there, oddly. And we'll look at it in infrared. There it is in infrared. So probably a foreground object there, as that object is blue, and the quasar is this reddish pink color. Again, if you want to read more about quasars, I don't know, go read up on this one, B0607-157. Quasars are a special type of active galactic nucleus, which has one of the poloidal field jets pointed directly towards you, which is what makes it look so bright. In the realm of cosmology, perspective is everything. So if you're viewing an edge-on disk galaxy, it's more likely to appear as a radio galaxy. If you're viewing a galaxy directly down the pole, it's more likely to be a quasar or a blazar or a Safer 2 galaxy or a BL Lacertae object, or as a more active object. One other thing I'd like to say about cosmology comes from our comments section. So thanks everybody who leaves comments on the YouTube videos. It often leads to increased understanding. Uroute W, shout out to Uroute W, who says, I don't know if you'll see this, but where do you stand? Is cosmology and geology utterly wrong? My response was, you be the judge. If stars do not form the way the current science believes, then solar systems probably don't either. How could they be right? If their observations are not without value and merit, but if 2 + 2 doesn't equal 4, our solar system is believed to have formed following a supernova because of the sun's and solar system's metallicity. Where do those heavy elements come from, folks? If they don't require a supernova, am I causing some gears to turn? Iron core planets, liquid metallic stars instead of balls of hot gas? You tell me. And our regular viewers sort of know what I'm talking about. More on this later. I don't want to spend too much time on it, as it is sort of an important day, as there is a geomagnetic storm on the way. And some folks are forecasting all the way up to a G3. We won't get too deep into it, as it's the daily space weather and we've got to continue on with the rest of the data. We don't want the video to be too long. Thanks again to our new viewers. Looking at the real-time solar wind, we've seen an increase here in the solar wind density, making it all the way up to 22.7 protons per cubic centimeter or so. Looks like we got up to 23 plus there. And that's a typical signature of a coronal hole wind stream. As you can see, it dips down here and the speed comes up at the same time. Looks like the beginning of the coronal hole wind stream is already here. I actually forecasted this to show up a little bit earlier. And there you have it, another forecast nailed. Here is the KP index, which has come back down, as we didn't see a very big increase in the speed. So don't be surprised to see a second pulse here. That could be the acceleration caused by the coronal mass ejection, as those protons have a tendency to interact with each other. So the current geomagnetism is only at a KP of 2. The KP index is a measurement of global geomagnetism. Here's a visualization of that based on the space weather modeling framework. It's 4 hours of data courtesy University of Michigan. This is the magnetohydrodynamic pressure in nanopascals. And there you can see some pressure variations happening in the magnetosphere. Next, we'll look at 4 hours of ground magnetic perturbations. And we're expecting some significant auroras to be sparked during this geomagnetic storm that is on the way. Probably some auroras already sparked here. We see major magnetic perturbations over the Canadian North Pole, which is located around here. Some perturbations over the Siberian North Geomagnetic Pole. Yes, there are 2 in the north, as well as pulses coming out of the southern Indian Ocean. The South Geomagnetic Pole is somewhere down here south of Australia, well off of the Antarctic continent, nowhere near the South Geographic Pole. We see an increase in the proton flux here over the past couple of days, just like we did with the last coronal mass ejection. Expect this to rise significantly higher here, as again, this coronal mass ejection is much more Earth-facing. It could be a dud. I'm not expecting to see as much of a geomagnetic storm as NOAA is, but I don't want to get too deep into that because I prefer to be right all the time. And there's the GOES X-ray flux over the past 3 days. Don't get your photons and protons mixed up, folks. I'll say this again. Don't get your protons and photons mixed up. coronal mass ejections are primarily made of protons, hydrogen nuclei. Solar flares are made of photons, and we measure solar flares in X-rays. Photons, protons, very different, especially in mass and in charge, as photons aren't the same sort of particle. Anyway, here's a star chart for you. I like to use in-the-sky.org and face mine to the south, and I like to draw in the ecliptic, shown there in yellow. As in the northern hemisphere, your ecliptic is to the south. Here's what's going on in the solar system. There's where things will be in a week, just coming off of the new moon on the 16th. Don't be surprised to see extreme fluctuations here in the GOES magnetometers, as again, there are two different series of protons on the way to the Earth right now. Some of them have already struck, and we're going to see all kinds of fluctuations in all of these things. Don't be surprised to see the GOES 16 shut off. Again, it's not because NASA is obfuscating the truth or hiding the data from you, and it's not because Nibiru has moved in between the Earth and the GOES 16 or anything like that. It's because of what's called a CCD bakeout. During a CCD bakeout, satellites shut down to prevent their circuitry from being destroyed by radiation. Next, we're going to look at the top view ecliptic plane field plot, part of the National Sunspot Observatory. This data is derived from 51 ground-based magnetometers, as well as magnetometers out here at Lagrange point 5 on stereo A and Lagrange point 4 on stereo B. It shows us the polarity of the heliospheric current sheet. So Earth is currently just recently moved into the North Pole current sheet, shown in green, and we're expecting that to continue for the foreseeable future, as the main solar activity is and has been in the southern hemisphere. Here's a line-of-sight coronal hole field plot, which shows you the B field as well in blue. And now you're looking at the line-of-sight view instead of as if you were looking down at the sun from the North Pole, because the last frame was the top view ecliptic plane field plot. It's the same data, just shown in a different perspective. And you can see coronal holes here, North Pole coronal holes shown in green, South Pole coronal holes shown in red. The data is 1 hour and 48 minutes old. Keep in mind the magnetic environment can suddenly change. Here's one that includes the solar magnetogram as well, the line-of-sight field plot. It also shows you the solar polar fields in green and red. And last but not least, we'll look at the chaotic environment of the solar corona, its magnetic field force lines, potential field surface source lines. Not a lot to say about that. It's showing you open potential field surface source lines in black, closed potential field surface source lines in pink. And if it's a coronal hole open potential field force line, it'll show that in purple. We do see some charging hazards. They've calmed down a little bit since I did show prep. They're mainly over Central America and Mexico right now. Here's a 1-year chart of the electron flux. That's another solon.info data point. And NOAA is forecasting another increase in the electron flux. I don't know why that would be. I would be forecasting a downtick here. I think the electron flux will drop. And electron bridging could actually accelerate the coronal mass ejection, depending on how far apart the coronal mass ejection is from the coronal hole wind stream, which is, again, forecasted to arrive first. Here you can see the electron flux already cratering. Again, that's what happens when a coronal hole wind stream arrives, especially when there's weak geomagnetic situation. Solar activity is actually low right now, following a significant uptick right at the beginning of solar cycle 25. Here's a visualization of the total electron content forecast. We see some minor anomalies here over North America. This shows you where GPS errors would be located, and this is a visualization of the entire air column in terms of how many electrons, the electron density. Basically, it's a two-dimensional visualization from the thermosphere down to your handset. Here's just a diagram of where satellites and where the Van Allen belts are located. It shows the inner and outer Van Allen belt, the location of the International Space Station, and so on. And geomagnetic storms are a danger to the International Space Station. They've got a radiation shielding room that they'll be spending some time in over the next couple days. And we see some likely protons here all the way down in the D layer of the ionosphere. So we'll show you that next. And when you see this attenuation happening here, that is an indication that we see some particles all the way down in the D layer. So you can see some absorption there at the 1 decibel bandwidth. Nothing to write home about yet. This will probably start to look a little more extreme if you want to follow this yourself. It's the De-Absorption Region Predictions, or DRAP. Here's a visualization of the ionosphere layer, courtesy Bureau of Meteorology, Australian government. Ionosphere looking fairly normal here so far. It's 1 full day of data. And we'll bring up the latest image. Keep in mind, folks, usually at nighttime the F2 layer turns into an F layer. When you see a red blob, that means that there's only sort of 1 layer there. So these are the different layers of the ionosphere, the D, E, and F layers. And those are all different atmospheric densities, obviously. Latest image there, 9:15 Universal Time. We see an uptick in earthquakes. Let's see if we see an uptick in volcanoes also. Abiko has upticked. It's producing a 15,000-foot ash plume. Sakurajima erupting as well, 7,000-foot ash plume above there. Fuego, I think that's an uptick at Fuego as it explodes. Flight level 160, it's producing a 16,000-foot plume of ash. Don't pole vault the caldera. Sangay is exploding. Flight level 210, don't do a back handspring over the caldera there. It's a 21,000-foot plume of ash. Revenador exploding, 15,000-foot ash plume there. And Sabancaya is reminding us not to tightrope walk the caldera. By the way, a guy did that, I think it was last year. Not at Sabancaya, I forget which volcano it was. But it was an active volcano, and a guy tightrope walked it. Yeah, for real. Sabancaya is producing a 25,000-foot plume of ash. So we see an uptick here in earthquakes. A bunch of earthquakes over the U.S., first of all. And some deep quakes, as we saw yesterday, such as that small one on Alaska. It's a 2.7 at 124 kilometers depth. Let's see what else we've got. I'll tell you what we've got. We've got a lull in earthquakes. 7, 8, and 9 magnitude earthquakes are at a very low level here. It's a drought. An earthquake drought's on an earthquake, so please have an earthquake plan. Be the man and not the person waiting for the cavalry to arrive, because many times if you're waiting for the cavalry to arrive and wondering who the cavalry is, it's probably because you're the cavalry. So, de oppresso liber, which means from the oppressed, the free. Largest of the past 24 may have been this 5.4 over Mexico. I should say under Mexico. So it is an earthquake drought, folks, and incoming solar protons are associated with large earthquakes. So nothing over a 6 magnitude here as the earthquake drought continues. Next, we're going to look at windy.com's pressure maps. I'll advance this into the GFS forecast for tomorrow. There's where we expect things to be at 12 noon tomorrow. A stagnant low pressure system there south of Iceland. Perhaps that'll be the location of a large quake. Also a stagnating low pressure over the western Aleutian Islands. And again, I'm located in Lehigh Valley, Pennsylvania. There's where the GFS forecast predicts things to be at 12 noon tomorrow. And that is Eastern Standard Time, the official time of the Smash News Network. Next, looking at nullschool.net's jet streams. This is the 250 hectopascal winds. There are the jet streams of the eastern world, and this is probably the most significant meteorological snapshot you could take If you wanted to look at only one data point on a worldwide scale, the jet stream gives you great insight. And check out the extreme bend there over the central Atlantic. Making two 180-degree bends over just a few thousand miles, as well as a significant anticyclone there over the central U.S., around northern Texas. You can see a clockwise rotation, as well as a powerful low here off the coast of South America near the South Atlantic anomaly, as clockwise rotations in the southern hemisphere indicate low pressure systems, opposite of the northern hemisphere. Now we're at lightningmaps.org checking out lightning strikes. Pardon my voice, I've been doing a little bit too much talking and yelling. Here's the GOES lightning mapper. Not a lot of bling. When I do my thing, bada boom, bada bing. From the wombs of the tomb, get the ricotta, bada bing, bada boom. To quote Danger Doom. Not a whole lot of lightning on the lightning mapper today. We see some snow hitting Pennsylvania and New York, southeastern Canada, and some heavy rains there over northern Oregon and Washington, which are taking their time and making for a soggy situation. Here's what's going on the cloud layer. I like to use the NASA GOES interactive weather satellite for it, and look at all the low clouds over the Atlantic and the Gulf. That is a major low cloud setup going on there. And for you new viewers, low clouds can be associated with cosmic rays. Here's what's going on in the water vapor, as we've got some cold air blasting in from Canada, striking places like especially Lake Michigan right now. A cold, windy day over Lake Michigan. There's the cloud layer once again, and there's the water vapor. It's the shortwave radiation map, by the way, which allows you to see clouds when they're not visible on the visible satellite. Stay tuned, folks. We've got some bonus features for you here. Keep your head and arms inside the SMASH plane at all times. Thanks for flying American SMASHways. We're going to show you the solar intensity gram as well as the colorized magnetogram to see what's happening. Again, don't forget to press like and subscribe on YouTube. Please share the content on your social media. Consider becoming a patron, etc. Visit our links. Pick up some merch. Maybe buy some Christmas presents. Are you safe yet? All right, here's the latest high-res image of the local yellow dwarf. A couple new areas of activity kicking up. Here's a little magnetic region. Here's a magnetic region. Here's the only sunspot we really see right now. And that is where the coronal mass ejection came from. There's a close-up. It's degraded a bit. Not really surprising. A couple minor umbrae there, it looks like, as well. Looks like all the sunspot activity is degrading. We've got some additional videos here for you. So we're going to show you the coronal mass ejection sparking solar flare. Here it is in 94 angstroms. A spectacular view, 94 angstroms there, of that solar flare that happened on Monday night. And the peak flux happened around 1630 Universal Time. Thanks to our patrons, the true source of funding for the content. Please consider becoming a patron once again. Patreon.com/smashomash. And we've provided some additional benefits today. Please consider joining at the $3 or more per month level, as we'll be eliminating the $1 and $2 per month levels due to things like inflation and underfunding at the end of the year. Thanks again to our patrons, the true source of funding for the Smash News Network. Here is some more great footage from the SDO. There's that solar flare. Here's me off screen. This is 335 angstroms, one of the many ionized iron UV emission spectral states. Here it is in 131 angstroms. And I think we have one more video for you here. We're going to show you the 48-hour SDO video in my favorite wavelength, 171 angstroms. Give that a minute to load. Thanks again for tuning into the Smash News Network. I've been your host, Dan, aka smAsho. And give that a minute, it'll be well worth it. It's 2 days of data from the SDO in 171 angstroms. Another one of the UV ionized states of iron. And we'll see you next time. We'll probably make another video this afternoon here at the Smash News Network. And may that solar wind be at your back.